here or whatever it is that you want to go do. Not in here, all right? Not in here. I guess you can't look for Pokemons in here, can you?
Yeah, sure you can.
Are there any in here?
I don't know. I don't play that.
Yeah, I don't either. So if you are sitting there using your electronic device in any way that's not connected to this class, 10% penalty on your next exam. That's automatically, you cannot get an A on that exam. That's it. You'll be asked to leave and I'll count you absent. So that's extreme, right? That's extreme? Yeah. Did I do it in your class?
You threatened.
I threatened someone?
Yeah, you
Okay.
were very serious.
Yeah.
2 times.
Yeah. I've been a little worse than that lately. I haven't threatened, I just do. So I've become even worse with this. I just make an example right away out of someone. So if anyone wants to be that volunteer, to be made an example of. And I apologize because there's that other side of me that understands, like, you're paying to be here, you know, this is college, man. I'm paying to be here. I should be able to use my phone. This is my classroom. I get to run it the way I want to run it. At some point in time, I'm sure down the road, I won't be able to do this. I won't be able to have these rules. But until that happens, that's my policy. Everybody needs to be focused on what's happening here. If you're not, don't come to class. If you really need to be on your phone, step out of the classroom. At least show me the respect of stepping out of the room. That fair? And then come back. But just don't do that 10 times, you know? Just You've signed up to be here for an hour, 40 minutes, twice a week, so be here, 100%. Behavior, same thing. Sleeping or being disruptive, same thing. So if you start feeling yourself, that nodding, you know, if you start feel that, everyone knows that feeling. Get up. There's stairs right here. Just go all the way to the bottom, jog all the way back up, go all the way to the bottom, jog all the way back up, do it twice, come back in, you'll feel like a new person. Right? You're ready to roll. Or just take a little 5-minute nap right there on that little bench. Don't sleep in here, right? That'll cost you big time. All right, I don't like making examples. I always have to like mute my microphone. I mute it and I'm like, hey, and I start, I don't like it. I'm not teaching college to be a babysitter. All right, that's not why I'm doing this. Tutoring, blah, blah, blah. Tutoring's across the hall. All right, if you go over to the tutoring 316 for tutoring, look for somebody who has graduated from calculus. All right, they're done with Cal 1, Cal 2, and hopefully Cal 3. Don't pick a tutor who took Cal 1 last semester and got an A. That does not mean that they're going to be able to help you. All right, I'm just warning you. All right, this is it's a community college. What you want is to find someone over there who is maybe in graduate school, getting their master's in mathematics right now, because there are a few over there, excellent tutors. I'm always weary of someone who just finished calculus teaching someone else how to do calculus, because they don't really have that true global perspective of the subject yet. So it's...
I ran into the same problem with the algebra.
Algebra, yeah.
Yeah, I went in there and for one of the homework problems, they're like, oh, this is the answer. Like, well, the book says it's this, and they're like, well, yeah, that's the answer. I'm like, well, you didn't get that.
Yeah.
They're like, well, that's your teacher. I'm like, okay.
If you are ever with a tutor and you feel like, yeah, this is not going well, then just don't go to that tutor again. You know, I mean, they're people.
Excuse me, sir.
Yes.
Sorry. Can you excuse me? I think I feel like I'm in the wrong class. I'm supposed to be at art class, though.
Art? Well, I appreciate you sitting through this.
I'm sorry. It's 303, isn't it?
Yes.
Yeah, I think you
Yeah,
might be in the
that's
wrong
what
building.
What's the building?
I guess I'm sorry. It's my first, second day, so.
Look, here we go. There.
Sounds funny.
It's art class now.
This is Art 101.
I'm sorry.
Okay. Well, good luck.
Thank you.
That's pretty good. We needed a laugh in here. Those are my office hours.
That was a good one.
Monday through Thursday, 9 to 10:45, I'm in my office. Unfortunately, right before this class, I have a class. So Monday and Wednesday, I'm in my office from 1 to 2:30. So really, I don't know how it's going to work out with this class, because after class I don't have office hours. And the only time before is from 9 to about 11. Now, if you need to make a special appointment with me, I can sometimes meet with students on Fridays. I forgot to mention this to the other class. Bonus points. Y'all love bonus points, right? I say bonus is, before I even get the S sound out, like bonus, and everyone's like, right? How do you get bonus in this class? Come see me in my office. All right? If you can't, we can work something out. But here's what I've always felt about calculus students. Is students start to come together, whether it be at my office or anywhere, and start to form groups. That's where you can really learn. And so if you can't come to my office and y'all are forming your own study groups outside and y'all are meeting on a regular basis, like here at the lab or somewhere else, if you all let me know about this group, I will give you bonus points for being in that group. All right? So I'm trying to encourage and promote collaborative learning amongst you and your classmates. All right? When you come to my office to meet with me, that means more people like try and do the same thing, then y'all meet each other, and then y'all decide, hey, look, we can just sit out here every day in front of his office and do our homework problems, and if we have a question, we can just knock on his door right there. And that, to me, that's my best students have always been those students who just sat there and worked outside my office. We have office, this is a top view, we have these little desks in the middle, and our offices are over here. And I sit in here, and my students can just sit at these tables and just work, and that's a great resource. Yes?
Do you have anything against us going to other math professors?
No? Sure. I mean, I'll always say, no matter what, whether it's a tutor or another instructor, you're always going to have different perspectives, you know, different emphasis. And man, I've eaten up so much time. My gosh, we need to talk about math. All right, I'm done. Are y'all done with questions or yes?
Did you say it's like possible to like get ahead in homework? Like just
Well, if you go watch the course videos and then you decide to go find a playlist on my YouTube that has my class lecture videos from like last semester or the semester before, you could theoretically get ahead. My internet students, I have Cal 1 internet students who are basically watching the course videos and watching old lectures and doing their homework online. So you could theoretically do that. Yes?
Is all the homework going to be off the textbook?
It'll be all out of here, yep. I might assign another problem that's not in the book. But. All right, I'm getting a headache because I haven't talked about math, so we need to talk about math. Any other questions? We ready? I feel like we just need a pause for a minute. We only have 30 minutes. Now, the camera, the way it's set up, and I'm going to be writing on this board, I'm going to have to stay within a certain frame here the entire time, but that's okay. I've done this many times, so it'll work. And the way this looks on camera, like on video, when you see it on YouTube, crystal clear. Like, this is a little blurry, this stuff, but like what I write down, it's going to be crystal clear. I'm going to look a little dark in there because of the way I have things set. I'm getting like maximum contrast so that when you watch a video, it's easy to see. So if you see me staying in here, between there and there, that's why. All right, we're going to talk about an introduction to this idea of the limit. And I need to make this a little bigger so you can see it. All right, there's a nice polynomial function. Everyone see it? I would like for us to discuss the behavior of the function at the value of x equals 2. So there are two sets of goggles that I'm going to be using today. I have my college algebra goggles. Take those off. I have my calculus goggles. All right? Two different views on this. First, let's talk college algebra. What I could ask you here is, what is f of 2? 8, right? So all that means is You know, you go out to x value of 2, you go up and you see how high that is. It's up there at 8, right? That's college algebra. That's evaluating a function at a point. We all good? Now, I take off the college algebra goggles and I put on the calculus 1 goggles, and what I'd like to know is, how does this function behave as I get close to 2 without actually getting to 2? So this goes back to that zoom in thing kind of idea. So if I were to start moving along, my x values are here. So right now my x value is 1.2. My y value is 4.032, right? I'm going to move towards an x value of 2. And I'm moving, notice, from the left side. Just keep an eye on the y values. Where are they headed to? They're increasing. What are they getting closer to? They look like they're getting closer to 8, right? 7.6, 7.7, 7.8, 7.9. I'm really starting to get close. I'm going really slow. All right? So, and it seems natural, right? If you were to draw this, eventually you would have to get to 8. So the closer you get to 2 from the left, the closer you get to 8. Make sense? So there's no magic here so far. Now, what if I change my perspective a little bit, and instead of coming into 2 from the left side, I were to approach 2 from the right? So keep an eye on these y values again. Y value is right here. Here's your x value. This time I'm approaching 2 from the right-hand side. So it went past 8, right? So that's okay. I want to get close to 2. Am I close yet? Not yet. Am I getting closer? Yeah, closer, closer. Getting closer. And what's that value? What's the y value getting closer to? 8. But this time it's bigger, right? So when I came in from the left, it was approaching 8, but they were a little smaller than 8. As I'm coming in from the right-hand side, it's approaching 8, but they were a little bigger than 8. Yeah? But both sides, both directions, I'm approaching 8. All right. That's it. That's the calculus goggles. Now, of course, we'll extend on this a little more, but we don't want to overcomplicate it yet. Same idea. College algebra goggles first. What's the value of this function at 2? And I'm going to continue to do 2 just because that's the way I set up these examples. What is f of 2 here?
On the left,
Nope. What's f of 2? College algebra goggles.
8 and 4.
Nope.
No, 8.
Nope.
Because it includes that.
So there's a difference between an open circle and a solid dot, right? Solid dot means that's what the point is defined to be. The open circle means it's not, right? Would it be possible for me to put the dot in here? Could I have 2 dots like that? It wouldn't be a function. It would fail to be a function because it would fail the vertical line test. The vertical line would cross through at 2 points. It wouldn't be a function. So we can't have that ever in this class. So f of 2 is what? 8, just like it was before. Let's investigate what happens as I approach 2 from the left. Whoa. Where's it headed? It's increasing, right? It's getting closer and closer to 8 again, isn't it? Oh, wrong one. So it's as I come in from the left, the value of the function is approaching 8. What about from the right? Here it comes. There it is. Okay. I'm approaching 2. I'm approaching 2. What's the value of the function approaching? Approaching. Looks like 4, right? Looks like it's approaching 4. But it never actually gets there. But if I got even closer, now I'm going to go real close. If I got closer and closer and closer, look at the value. It's getting closer and closer to 4. But there's a hole there, right? There's a hole there, so I can't ever be on top of 2, right? I can't move that point to 2. If I do, what happens? It goes up to 8, right? But as I get closer to 2 from the right-hand side, the value of the function is 4. So do you see the difference between this one and the one before? In the one before and in this one, f of 2 was 8. But from the left side, they both went to 8. On this one, the right side goes to 4. The previous problem, it went to 8, right? Can you see over there? I mean, not really? Well, we should, okay, yeah, let's next class, let's try to push these back, and because I usually do a pretty good job of staying out of the way, but okay. What do we have here? College algebra goggles first. F of 2. 6, right? 2, 6. Done. Calculus goggles. Come in from the left.
It gets really close to 8, but then it goes right to 6.
Yeah, this time I'm not going to use that slider. I'm just going to use my fingers. I'm going to walk. I'm walking along the function, right? Going up. The y value is approaching 8, right? As I get closer, it gets closer to 8. Do I ever get there? I don't care that I don't get there. This is the idea of the limit. You're talking about what happens as you get closer and closer and closer without actually ever having to be there. So this is approaching 8 from the left. How about from the right? It's approaching 4 again, right? So we walk in, come up, start to come down, and then that y value starts to get closer to 4 again. Are we all clear? No questions. Let me go back to this one. All right, I've been telling you like college algebra goggles and calculus goggles. Now instead, I'm going to use college algebra notation, calculus notation. How do I tell you, how do I write down so that other people understand that as I approach 2 from the left, that this thing goes to 8? How do I write that? This is the notation. I write LIM, which stands for limit. This tells you right away we are in a calculus class, okay? I'm going to let x approach 2. Now what am I looking at? I'm looking at this function f of x. So this limit, LIM, tells you we're going to be approaching, without actually ever being there, we're going to be approaching 2. What are we working with? We're working with this function f of x, which is this. And I'm telling you that that's equal to what? From the left it was what? 8, and from the right it was 4. 2 different answers. So somewhere in this notation I need to tell you which side I'm coming in from. And this is the way we do it. I put a negative sign here if I want you to come in from the left. I will put a positive sign here if I want you to come in from the right. Notice it's a superscript, top right. Okay, that indicates the direction. The way to remember it, negatives are here, positives are here. So negative, you're coming in from the left side. Positive, you're coming in from the right. What was the answer to this? Oh, careful. Coming in from the left. 8. Now, let's do it for the other side. Limit. X approaches 2. This time from the right, so I put little plus up here. Of the function, this is equal to 4. College algebra, what's happening at 2? Sure. This is calculus. What's happening as we approach 2 from the left? It's approaching 8. Calculus, what's happening as we approach 2 from the right? It's 4. Understand all this notation? Questions? This one's harder to see, so I'm going to have to show this to you. I'm going to have to use the computer to help. I'm interested in what's happening right here. This is 2. This is x is 2, all right? First of all, what is f of 2? College algebra. Look at the function. Try and plug 2 into that function. What do you get? You get 0 over 0, don't you? Which means it's undefined. And that's why there's a little hole here. You see that? See the little hole right here? Okay, there's a hole. This is back in college algebra. This is a rational function with a hole in it. So if I'm trying to tell you that I cannot plug in 2, right? I can't plug it in. It's because it's undefined. So my college algebra perspective is that f of 2 is undefined because I'm getting 0 over 0. But what about the calculus perspective? What's happening is I approach 2 from the left of this function. Can you tell? Does it look like it's headed somewhere? If I start moving in this way, right? Am I approaching a y value? Sure looks like it. Let me move it in here for you. Here it comes. The blue is the y value. Oh no, wait. The blue is the x value. I take that back. Can you see the y value? What does it look like it's getting closer to? Negative 2 point. Is it moving? Oh, I'm in the wrong one. What does it look like to you? Negative 0.25? Negative 0.25 it looks like about. Do y'all see it? So I'm having the computer do a lot of work for us right now. The computer's going in, it's plugging in 1.955 into here it's computing, and it's getting this answer. And as I keep on plugging in more and more points, it keeps on giving me answers that are closer and closer and closer to, it looks like, negative 0.25. So I'm going to put here negative 1/4. 1/4? 0.25? Negative? That's what it looks like, right? How about from the right-hand side? Looks like it's headed towards the same place, right? I'm coming in this way, and it looks like that y value is also headed to negative 1/4. Now, please understand, we just did that by inspection and using the computer to help us. We do not know, like if I just gave you this function, I tell you, hey, what's happening is you approach 2 on this, you would not be able to give me these answers without the help of the graph and the computer right now, right? We will be able to do it, though, by the end of next class, by hand. All I'm trying to get you to see right now is the two perspectives, college algebra versus the calculus, the coming in from both sides. Do y'all see how this might help us with the whole tangent line idea? We have a place, we have a function that at a certain point we get 0 over 0, but as soon as you move a little bit away, you've got a nice value, right? And that's exactly what was happening with that point that I had earlier, where I was trying to move that secant, that point on top. As long as we are just a little bit off, we have a value. As soon as we moved it right on top, 0 over 0. So it is possible to have functions behave that way, and this is an example of one. All right. Take a look at this one. This is an interesting function, sine of x over x. What's happening at 0? So let's do college algebra first. What's f of 0? Undefined. Right? Undefined. It's undefined because sine of 0 is 0. And then divide by 0 is 0. 0 over 0. It's undefined. What about from the calculus perspective? What is the limit as x approaches 0 from the left of this function? 1. You can tell just from the picture, right? You can tell from the picture. How about from the right? It's also 1. Huh. Is this the first one we've done, at least in a while, it's the first one where from the left and from the right it's the same thing? The last one was? Was it? Oh yeah, yeah, it was. Take that back. See, we're getting the same answer from the left and the right. Aren't we? This is kind of a special case. When your limits from both sides are going to the same value, we have an even shorter way of writing that down. And this is not shorter, but it's a little more condensed. This is what I write. Limit x approaches 0, f of x equals 1. So what's the difference between these two and this one? Doesn't have the plus or minus, right? It's not there. So what this one means, if someone were to write this down, or if you write this down, what you're telling the reader, what you're telling me, is that the limit from both directions is 1. If you put the negative, you're telling me only from that direction it's 1. If you give me the positive, you're saying only from that direction it's 1. But if they turn out to be the same number, there's no need to write the plus or the minus. It's understood this means from both sides. Understand? It's a big thing to make sure you're clear on, because if you write that down, you're guaranteeing both sides are going to the same place. Ready for the next one? Next one's crazy. Ah! What in the world is happening here? Sine of 1 over x. Sine of 1 over x. This is a really cool function. And I think to kind of get an idea of what's happening here, you hopefully remember from college algebra what 1 over x looks like if we graph it. If we graph that, it looks like this. Those are arrows. It's asymptotic, so it kind of dives down and goes up. This is one of those functions you need to know what it looks like. Remember I said I skipped sections 1, 1, and 1, 2? This is in 1, 1, and 1, 2. So I have this function in here. If I let x try and get close to 0, I get division by 0, right? But what happens to 1 over x as I get close to 0? What happens from the left side? Where does it go? Down to negative infinity, and on the right side, up to positive infinity. That's what's happening at 0, right? And then we're taking that and we're sticking that inside of a sine function. And so the net effect is this. The sine function is trying to oscillate between 1 and negative 1, right? Trying to do its thing. But as it gets close to 0, this inside here becomes infinite, which means that the sine function has to start to do more periods of oscillations, right? In a smaller and smaller interval. And the closer it gets to 0, the more infinite it becomes. So it starts to try and draw these things, and it goes nuts. So I think what I can do is I can try and come in from the left, and I can actually play this. Yeah. So watch it. Can you see it? Goes up. Uh-oh. I went too fast. And let me zoom in. Too much. There we go. Let's try and watch this, see what happens here. It's going to go up. Oh, that was a little infinity. Sorry about that. Smaller steps. There we go. See it? So that little point's trying to move towards the origin. It's trying to be a sine function. And up, down, and it freaks out. Tries to do it. So my question now is, first of all, college algebra, what's f of 0? Undefined, right? You can't plug 0 into this function. Undefined. I might write UND from now on for undefined. Tell me what's happening as a limit as x approaches 0 from the left of this function. Is it headed somewhere? As I come in, is it headed towards a singular value? Where, up here? Yeah, but then it's going to wind up over here too, right? Like there, it's down there, and it's up there, and it keeps oscillating, doesn't it? It's not headed to one particular value. As soon as it moves a little bit more, it's at a different value of sine, and it's not going to anywhere. This is our first example of a crazy function. See if I can zoom in more. See, look, even the computer freaks out. This is the computer's not knowing how to handle the craziness of this function. It's given up, and it started to draw it like jagged edges. That's how nasty this function is as you get close to 0. It says it's 1, but that's a mistake on the computer. So it's not headed towards a number, is it? From the left, it's not. It's oscillating infinitely many times. And so how do I tell you that this limit doesn't go anywhere? Does not exist is what we say. This limit right here does not exist. D-N-E. D-N-E. That's what you write. Or you write does not exist. So see the difference between these two words? Undefined, algebraically, you can't plug in 0. It's not defined. This limit doesn't exist because it's not going towards a certain value. How about from the right side? Same thing, doesn't exist. So could I just take that off? Take that little negative off? And now that implies both sides, doesn't it? Okay. I can remember this problem being on a test. No, it was a quiz. I gave a quiz once, a couple of semesters ago, and I drew this picture. And it was and I was asking about what the limit was as you approach 3. Oh, I need to put a value here. So here's my question. What's the limit as x approaches 3 from the left of this function? 1. 1? As I come in from the left, it's headed to 1. What's the limit as x approaches 3 from the right of this function?
Does not exist.
Oscillation, does not exist. DNE. What is f of 3?
Undefined.
Undefined. There's nothing there, right? There's an open hole, it's not defined. UND. See that?
So the limit of 3 does not exist.
Okay, so that's a great question. What about this? What would that be?
Doesn't exist.
That does not exist. Does not exist. We always reserve does not exist for limits. And we reserve undefined for evaluation of functions without limits. Y'all hanging in there? It's just day 1. Okay, I know it's a lot easier for me to stand up here and talk. I know what it's like to sit through a long talk, and I wish we could play like, what's that, heads down, thumbs up, or what is it? I wish we could play games in here, you know, pin the tail on the donkey. Can't. We got a lot to do. All right, how about this? Limit x approaches 0. And do you see a red line down the middle? That is the computer freaking out at 0. Your graphing calculators often do the same thing. They're trying to draw the function, and it's like, whoa, I need to draw some really, really big negative numbers, and then on the other side, they're really big positive numbers, and your computer, the algorithm it's running, says, shit, and it connects the two ends at some point with a line. It just kind of gives up. That's what's happening. That is not part of the graph. That's a limitation of the software. It may not say shit. I say shit. It may not. I apologize. I need to work on my language, man. I really do. Limit x approaches 0 from the left. What do you got?
Negative and negative.
Limit x approaches 0 from the left of this function is, what are you saying?
Negative.
Negative infinity. Good. Now in the book, in the early sections of this book, they might say does not exist. Because in the beginning of this book, they say, hey, look, if this happens, just say does not exist. But later on, they tell you, hey, if that happens, say negative infinity. So I'm just going to start now by saying negative infinity. So as you go from left, it's heading to negative infinity. Negative infinity is not a number, right? It's an idea, but the limit is an idea. It's that you're heading somewhere, right? How about the limit from the right? Whoa, too many arches there. This is positive infinity. So can I just do this then and not put anything on there and just be like, well, it's, I don't know, plus or minus infinity or something? Is that okay? No. Unfortunately, positive and negative infinity, even though they're not numbers, they aren't the same. And so since they're not the same, we can't do this. This here we would have to write does not exist. They're not equal. They're not the same. If these are not the same, this limit doesn't exist. Individually, they might exist, but together they don't. It's a strong condition to say that the limit as x approaches some value exists without the plus or minus. It's a strong condition because it's both sides. What's f of 0? We didn't look through the algebra eyes. F of 0.
It's undefined.
Undefined. Undefined. How about this one? We got to go quick. I only have 4 minutes. That's infinity on both sides. So could I do it just with one? Yes. This you could write. This implies both sides headed to the same place, positive infinity. What's f of 0? Undefined. Questions? I'm gonna knock this out. Okay, this is all definition stuff. We can talk about this later. You can watch the video on that too. Look, I'm introducing the notation that I've been using this whole time, okay? This is me going back and using the notation on all the problems we did earlier, just using proper notation. I'll do this one as a quick example. I can write limit x approaches 2 of f of x equals 8 on this problem, can't I? Because it's from both sides. This one, I can do the left limit goes to 8, the right limit goes to 4, right? I need to get you to one last thing so that when you go home you're not like, what? Oh wait, I went way too far. That's next class. Where is it? Oh, why isn't it there? Ah, there we go. Okay. I understand there are 2 number 2s. That's a typo. So this is kind of a reverse process of what we just did. Instead of me giving you a graph and asking you to look at the limits, this time I'm going to give you some information about the limits and about the function. I want you to draw me a graph. So when we do this, I want you to understand everybody's answers are going to be different. All right? Everyone's answers are going to be a little bit different. So let's start by looking at this and knocking out the algebra stuff first. Let's get the easy stuff out first. F of negative 2, that's an algebra problem, isn't it? F of negative 2 is 0. It means I go to negative 2 and I go up nowhere, 0. And I put a dot there, right? Done. Then what? F of 1 is 2. Go out 1, go up 2. We all agree? Man, this is easy. All right, f of 4 is undefined. I just need to keep that in mind, that at 4, I should have nothing. It may not be, it may be a hole. You know what I'm saying? It could be an asymptote, it could be a hole, so I don't know yet. All right, let's look at this. Limit as x approaches negative 2, be careful, negative 2 of f of x is 3. I intentionally put negative 2 because I wanted you to maybe make the mistake of thinking that meant from the left. That doesn't mean from the left. This is negative 2. If I would have meant from the left, there would have been a little minus up there, right? Top right. It's not there, so what does that mean? From both sides, it must approach what? 3. So here's 3, do you agree? So if I go to -2, I need to be approaching 3. I'm going to put an open circle here. That means out that side and out that side. I'm just draw little connectors. See, my graph is coming into 3 from this side and coming into 3 from that side. Do you understand how that would work? I'm not going to draw anything else because I need to put all this information together, and I have no more time. Should I finish or? Okay. Limit x approaches 1 from the left. From the left is -1. Here's 1. From the left side, I need to be down -1. Here's -1. Put a circle here, little squiggly out that side. That would approach -1 from the left. How about from the right? I need to be approaching 2. So here's 2. Hey, wait, there's a dot there. I'm just going to throw a little connector on the outside of that. That comes in from the right, heads to 2. As I approach 4 from the left, infinity. 2, 3, 4. Here's 4. From the left, I'm supposed to go, so I'm going to go like this, and I'm going to put a dotted line up there, like that. That makes sense? 4 from the right, I'm supposed to approach 0. From the right, 4, I'm supposed to head to 0, right? What about at 4? Open circle, because it's undefined, remember? That was that last piece of information? And this is it. This is the template. Now I just need to finish it off. I need to just draw it however I want. I'm free to fill in the blanks. So I'm going to be fun here. I'm going to go, yeah, it does that. And then here I'm going to connect these two together like that. And then just maybe squiggle that down. And then this one up here, I'll make it go like that. There we go. That's my function. It satisfies all the criteria. Make sense? Okay. All right. Do your homework. Watch my video if you need to. Have a good rest of your day.